Hello and welcome to our webinar, Managing RightScale on RightScale. Thanks for joining us. Before we get started, we're actually going to launch a couple polls. We'd like to learn a few things about our audience. So if you could go ahead for the first question and answer. Are you using the cloud infrastructure today? So infrastructure as a service tools such as Amazon EC2 or Rackspace. Maybe you have a couple applications in production or just one, maybe you're just beginning to explore, or you don't actually have anything running in the cloud yet. So go ahead and choose the one that is most appropriate for you. We'll let this run for a couple more seconds and then push out the results. Okay, interesting. There's actually a pretty good mix of you guys with varying levels of experience. That's really helpful for us to tailor our presentation to you. Next question. What's your role? It's pretty simple. Straightforward, self-explanatory. Just choose one. We'll let this run for a couple more seconds. This also helps us understand who you guys are and helps us tailor our presentation to you. Again, an interesting mix. A lot of you are architects, and then a good mix between other roles. Thank you. Last question. So we're curious, what is the number of servers in your production deployment? And this can be in your own data center, this can be in the cloud, it does not have to necessarily be in the cloud. We're just curious how many servers you have running. Leaving this open for a couple more seconds. And then a lot of you in the 10 to 100 range, and then the rest are kind of varied throughout. So cool, thank you so much for your time, and we're going to go ahead and get started now. So I would like to introduce our panel today. Our presenters include Rafael Saavedra. He's the VP of Engineering at RightScale. And then I also have next to me Chris Horn. He's the Director of Product Marketing, also here at RightScale. And then on our Q&A line, we have Doug Johnson. He will be answering your questions as the webinar goes on. He's a pretty cool guy, so feel free to shoot him your questions as they come up. What you can do to submit your questions is use the GoToWebinar Questions panel. You can just type in your question at any time, and Doug will answer that. We'll also take a couple of those questions that are more broadly applicable, and Rafael and Chris can address those live on the air. And with that, let me pass it off to Chris.
Thank you, Sarah. So to give you an overview of the topics we're looking to address today, Rafael's going to walk us through managing RightScale on RightScale, effectively how we move from development and staging into production environments, and then how we manage that production environment with another meta instance. We'll take a look at the production system and its components, how we monitor large-scale production systems. Then we'll talk through some of our favorite RightScale features that make life simpler and some of our not-so-favorite features where there's room for improvement. And finally, we're going to close out with a walkthrough of how we deploy RightScale when we upgrade it and walk through some of the best practices associated with that. Our goal is really to deliver some insight into how we manage large-scale applications on the cloud securely, scalably, and in a highly fault-tolerant manner. And again, just to reiterate what Sarah noted, please do submit questions as we go through. That'll also help keep this interactive and tailor it to the information you're looking for. Rafael?
Thank you, Chris. Okay, so let me start from the very beginning, something very simple. Welcome, everyone. So basically, what we have is the cloud, and it's well, this cloud that I'm showing represents all the possible servers, and then we know that RightScale runs in the cloud. That means that our deployment is in the cloud and all the servers are there. But our application, basically what it does is that it's a management platform for cloud deployments. That means that we control also our customers' deployments in the following way. So by using the RightScale production, you can basically connect to your deployment and do whatever, all the nice things that you love about RightScale. Or if you are not familiar with RightScale, I encourage you to basically look at it so that you can see the potential that it has. Now, given that RightScale is also a production system in the cloud, well, we need a management platform to manage it. Well, and what best platform than RightScale itself? So that means that we can replace these customers and in a way have other RightScale systems managed by RightScale. And in particular, what happens is that in our development process is that our programmers basically launch their own version of RightScale, what they're doing, developing features, and they manage it through RightScale itself. Similarly, once we are ready to go to production, what we do is that we put all the new changes from the new release into a staging system that is managed to the RightScale production system. And, well, sometimes we want to test whether this staging system with new features really is performing or is behaving as we expect. Well, so what we do is that we use that staging system to launch other RightScale systems, and it can be either a development system or it can be another RightScale staging system. It can be whatever we want, and we can go there recursively. Now, this looks great. The only problem is that everything is running on the cloud. So if something bad happens, that basically the cloud is unavailable, well, we need a way to basically solve the problem by bootstrapping, basically launching new servers. So we need another RightScale system that is going to manage the RightScale production system. And we do that by basically using either a system outside of the cloud, or we use it maybe in a different cloud. And here I'm just going to show it in this particular way. That is, we have what we call the RightScale Meta production system. That is a very, very small system that basically we only have the accounts that we use in production. They're completely isolated from the production system. And we use it so that we can launch new servers, we can fix problems, and basically we can do the nice things that you normally do in your deployment, but we do it on ours. Please feel free to ask questions. I think this is a simple overview. So let me go through the different systems that I just presented. Basically, we have a multitude of RightScale systems. We have the Meta production that manages the production system, and basically, and most probably you are not familiar with it because you only the production people have access to it. And currently, it lives outside of the cloud, containing production. Meta is extremely secure. It's accessible only by a handful of operations folks. Now, then we have the big production system that is what you know as my.rightscale.com. And this is a big deployment. We are reaching 200 servers. And with a large fraction in the EC2 US East, it's the most stable and also is the one that offers the most features, and also is in the middle between Europe and the US West. So it's a nice way of having it. However, we also have servers in other regions of EC2, AWS, and also in other clouds. Now, we have servers located in every cloud to achieve high availability. And we make sure that the servers are allocated in well-defined availability zones so that we try to minimize disruption in case one availability zone goes down. Obviously, if you put all your servers in all the availability zones, then if one of them fail, well, some fraction of your servers will go down. If you put it only in one availability zone, well, you're minimizing the probability that any zone will fail. But if the one that you're using fails, then all your servers are unavailable. So we try to have a good mix of zones. And, well, we need also a variety of staging systems that we use for integration and QA. We basically make releases every 6 or to 8 weeks, and therefore we have to be testing our systems regularly. And the way we test it is that we launch a staging system that we manage to the production. We also have systems in which the salespeople can do betas, or also we do demos. Also we have showcase systems maybe for some presentations. And in the end, well, the developers, they also need their own simplified version of the RightScale so that they can test new features. They can also maybe debug escalations and so on. And we have a very simple development system that is available at the click of a button. The nice thing about the cloud is that if you need 20 systems, well, you can just ask for them and you just pay for the time that it takes for you to use them.
Quick question here, Rafael. One of the questions that came in is how many VMs are typically running in production? And I think we've addressed that with around 200 servers.
Yes.
Is that right?
Yeah.
And then the next one, how many people operate your production service?
How many people? Well, formally there are only 2 people. However, in reality, I would say maybe there is the 2 people in operations and also Thorsten, the CTO, and myself, because we started basically managing our own system, sometimes we help in that respect. But I think that only 2 people are required for 200 servers.
Thanks.
At this point. Now, as you can see, I don't know if you have read some of our blog entries, but in the last year, there was a massive increase in cloud usage. And in fact, we have year to year, around July, 1,000% increased usage. And here we're just giving you a qualitative view of that. But the number of servers that we're managing through RightScale has increased significantly. And that's great news for everybody because it just basically highlights the acceptance of cloud and that people are starting to deploy more serious applications and basically with more servers and do very serious work on the cloud.
Okay. And another question that came in on the last slide, the person's asking, what is the value proposition for a multitude of clouds, or I guess getting back to running in or locating servers distributed across different cloud infrastructures and availability zones?
Well, I think there are multiple benefits. Maybe the most important one is you want your servers to be as close as possible. You want our production servers to be as close as possible to where your servers are going to be launched. For example, for those who are familiar with the features we offer, the servers that you launch, we monitor them. We also collect log information. So we also provide mirrors so that you can basically download packages as fast as possible. And you don't want to, if you are basically running in a cloud, you don't want to basically go to a different cloud, maybe across the world, just to download that information or to push the monitoring data. You want to have it as close as possible to where you're running. The second and maybe most important benefit is, well, clouds have been quite stable, but it's clear that every cloud and like any server, sometimes it fails, or sometimes there are blackouts. And if you really want your cloud to continue operating, you have to basically have less dependencies on other clouds. The more you have dependencies on clouds that is not where you're running your servers, the probability that when you need to launch a server, maybe that cloud is down, increases. So we really were committed to try to minimize and eliminate that problem.
So, and a clarifying question was, what do you mean by every cloud? Do you mean like AWS and Rackspace, et cetera?
Every cloud in which basically we support.
Okay.
Yes.
And then
Now, let me just say that doesn't mean that we have the same number of servers on every cloud. At this point, most of the, let's say, production servers, the dashboard or the API, right now reside in EC2 and AWS. However, we're based on all the support systems that you require when you launch your servers. We're trying to basically push them to the other clouds.
And the follow-on question, what kind of instance sizes are you using for production?
It's a variety of instance sizes. We go from, I would say, well, maybe large or extra large to quadruple extra larges. And we have quadruple extra larges for our databases, which basically has grown quite significantly. So it depends. We try to basically optimize the performance cost, and so we're revising the instance sizes regularly.
Thank you.
Okay, so let me give you some interesting RightScale numbers. We just basically reached the 2 million servers launched by RightScale. For those of you who were following, it took us less than a year to do the second million, and we believe that we're going to go to 3 million before the end of the year. We are continuously monitoring more than 70,000 servers. And just some numbers, every day at RightScale, 2,000 arrays, basically resize actions are executed. That means that an array it's a dynamic way of increasing the availability of servers, maybe your app servers, or maybe a grid computing. So 2,000 arrays basically change its size either by launching or by terminating instances. Also, we monitor and we trigger 35,000 alerts every day. That means servers that somehow are indicating to their owners that some action is required, or at least that something is not performing as it should. That means that we send 20,000 escalation emails to users, and now we're monitoring data, and this data, I think, is from 2 months ago, was reaching 9 terabytes per day. And our login data is 1.3 terabytes per day. So that's a significant number of volume. Now, let me give you a simplified view of our system. I don't know if you have a question?
No, you can continue on.
So this is a very simplified view, and you can imagine it's very similar to maybe what you have is we have some number of front ends, that basically take requests from users, either for the dashboard, the API, and so on. Behind that, we have our main applications, and in a simplified way, we break it into two parts. The dashboard, that is what you normally use, basically is when you interact with our site, and the API, that means that if you have some scripts that automatically are basically accessing our site, you normally do it through the API, and we have servers so that we separate the traffic. Behind that, we have our databases, and we use a master-slave configuration, and we have all the databases for replication and also for read the slaves to speed up some of the actions or to offload the activity on the master. In addition, this is your vanilla, more or less, multiple server configuration for a website. Now, more specific for RightScale, we have a collection of daemons, and we have a large number of them, and these daemons are specialized programs that normally they do some action that is specifically, for example, they talk to Amazon EC2, and they try to get information about every server that is running and that we know about, so that we can update changes on the state. For example, if you terminate an instance, and you may terminate it either to RightScale or you may terminate it directly through your machine. Well, we need to detect that something has changed so that when you look at the dashboard, the information is up to date. So for every cloud and for every region, we have daemons that basically pull for resources. In the same way, the monitoring data or the alerts or the work units, if you are running write scripts, also we need daemons to take care of all these different activities. And we have like in the 10, maybe 20, 30 of these daemons and machines. In addition, we have support services, and we provide, for example, we mirror some of the packages, for example, CentOS and Ubuntu and Rails gems, so that we don't depend. And sometimes the mirrors or the normal mirrors are not available. So we try to minimize the disruption when you try to launch a server by providing redundancy in ourselves. Similarly, we have hundreds of servers that are capturing monitoring data. That means are the little graphs that allow you to see how your servers are performing, and that allow you to put alerts so that you can see that everything is behaving as it should. Similarly, we capture login information so that if something happens to your server, that login information is outside so that you can recover it and you can look at it. And finally, we have a collection of other servers that I just put here as folders. Okay, there is a question?
Yeah, I've got a couple of questions that have come in. The first is, do you use AWS MySQL service or the RDS for the databases, or do you just run the databases on your own EC2 instances?
We use the RightScale master basically the template solution. We provide our own solution. We have done that from the very beginning, more than 3 years ago, and we can continue improving it, and that's what we use and we've been using for the last 4 years, and it has basically scaled from being a small instance 4 years ago to being a basically quadruple extra large server today.
Okay. Next question, how can a cloud fail if it's properly architected? Are you changing the definition of what a cloud is?
Well, failed is it's very generic in the sense maybe you don't have access, maybe the network, there is some problem on the network, and well, the cloud is not failing, but if you don't have access to the servers, well, then in that sense, you cannot launch new ones, you cannot connect to your servers. So in some cases, for example, 2 years ago, there was some problems with S3. S3 was unavailable. Well, and if you need some information that needs to be downloaded from S3 in order for you to configure your server, well, you may be able to launch the server, but it cannot configure itself. So when I say failure, it's just a generic way in which something can go wrong, basically.
Right. That you work around with redundancy.
Yes.
To preclude against. And the next question, are the issues running on the cloud more frequent than having a managed server solution? Or would they be the same?
I would say that it depends, because in the managed solution it depends. The quality varies significantly from one to another. Now, it's clear that in the cloud, the idea is that part of the value proposition is that the servers, in a way, are commodity servers. Some of them are cheap servers that can be replaced. So it's possible that you can see maybe higher rates of failures. However, the advantage that you have is that there is always 100 servers waiting on behind. And if you architecture your solution correctly, then you should be able to basically withstand failures. In fact, you should architecture any solution in a way that takes into account failures, because they happen. They always happen.
And next question, and this goes towards operations, is the interaction between meta-production and production automated at all, or is it mostly a manual with override scenarios?
I think it's a combination of factors. I would say that RightScale in that sense is pretty conservative. We tend not to automate things in which we can see some ambiguity. For example, if something happens on our database on the master, well, we don't automate, for example, the failover to a slave. We always require that a human looks at it, because, well, we need the person to really make a good judgment. So my take is RightScale provides you a way of automating a lot of these tasks. It's more the philosophy of the company, how you feel comfortable whether you use it or not. And again, I repeat, we tend to be conservative in that respect.
And we've just gotten a flurry of additional questions in. Is there one big master database, or do you partition user data across multiple databases?
Well, let's say that in the past there was massive database. We have basically moved away from that, and now we're basically having more like services around. RightScale is going to be a collection of services, so there's going to be a collection of databases.
Yeah. Okay. And towards monitoring, how many instances can each monitoring server support?
Well, it depends on the instance type. I think in the hundreds. I would say it's more than 100, less than 1,000 for sure. But I think what we use right now, it's in a couple of hundreds.
Okay. And then around the daemons, do the daemons store data straight to the database, or do they go through layers in the main application area?
I think, again, things have basically evolved. In the old days, they went directly to the database. Now it's clear that in order to scale, you have to decentralize the storage of information. So we're moving away from that. I think everything that I'm saying, it's a snapshot of what we do, how we do things today. These are evolving, and we're becoming more a distributed system. So we're pushing more of the information to basically to the leads and to the services that require it.
Okay. Another question around operations. How do you deal with load balancing?
Okay, I don't think that is concrete enough, the question. Well, the load balancing in the sense that the front ends use basically a round robin to load balance the request for the different application servers. Now, this is just from the perspective of the front ends. There's a lot of systems here and a lot of potential bottlenecks. So we go to a lot of analysis to make sure that we have a balanced systems, and we do rebalance quite frequently.
Okay. Two related questions related to alerting. First is, what is the topic breakdown on alerts? And the next question is, what are the top 3 alerts we see? What types of things are we looking for?
Okay, well, I think the most important one is that your server is unavailable, that somehow your server is not responsive. And that's the most important one. The second one is maybe the load is too high. So somehow you may need to launch a new server. And another one is maybe the I/O is too high. So that's especially critical for a database. Once your database starts doing I/O, the performance degrades rapidly. So again, it's application dependent, it's server dependent, but I would say those 3 are the most important ones.
Okay. And this one may be a little personal. What's the version control systems you use, and are they running within the production cloud?
Well, the version control, I think we use GitHub, basically.
Okay. Thank you.
So I'm just going to try to, I think there have been a lot of interesting questions, so maybe I'm not going to spend that much time in some of these slides. It's just more for information. But, well, what is that our users are doing? In a very, very broad view, we have the dashboard, that is when you're basically working with RightScale. We have the API. We have monitoring graphs and event notifications. So event notifications is the things that you see on your left-hand side panel that tells you, hey, your server is booting, you're executing a write script, and so on. And most of the requests are basically monitoring updates. Like 85% of the requests is just to monitoring data. It's a huge volume of them. However, the amount of data tend to be small, so they only represent 70% of the bandwidth that we use. The dashboard and the API calls are heavier requests, So that even when they represent only 7% of the request, they correspond to 26% of the bandwidth. So it's just some statistics to give you more or less an idea. Now, I think it's obvious at this point, given the first slide, that is, we eat our own food. That means that we use RightScale as a management platform to manage RightScale, so that we know exactly what it is to use it. We see we take advantage of the new features and the excellent goodies that we provide on every release, but we also experience some of the limitations. And for example, this is a view of the actual deployment maybe a couple of months ago, and it tries to be just generic, but basically says we have a core deployment, there are some servers, we use quick monitoring to basically monitor the activity on the different servers, and it's basically the same thing that most probably, if you're a customer, you use yourself. At the same time, we leverage server templates, that is our magic sauce, or something that we believe it's very powerful, that allows to, in a very reliable way, launch servers and making sure that they are configured in the same way. And what happens is that we create server templates for every release, and we preserve the ability to launch exact configuration of parts version. So for example, in every sprint, we update the server template, we create new ones, and we make sure that, as you can see here, that each of them can be executed in the different AWS clouds. Here we're just showing us, this is an older snapshot, so it looks basically at only three of the regions on AWS. Now, we also make extensive use of security group to isolate servers and make sure that there is a need to access between them, so that the application servers are the only ones that can access, for example, the database, and that also they can also be accessed through the front end, so that we have a secure system, and we basically revise these and try to improve continuously. Similarly, we rely a lot on monitoring and alerts, and here are just some examples of the kind of graphs that we monitor every day. So, for example, this is the API network activity versus the dashboard network activity. And what I want to show you here is that different servers and different uses basically conform to different patterns of activity. In the dashboard, because people, it's basically humans, the ones that are interacting with the system, it follows the normal working activities of people. That is, Saturdays and Sundays there is low activity, and during the days there is activity basically in the waking hours, but at night basically goes down. In contrast, the API, the activity is continuously the whole day, and the reason, well, here I'm just showing you basically 12 hours, but the reason is that these are basically automated scripts and they don't sleep. So that's the reason why we discriminate between the traffic going from the dashboard and the API to make sure that each of them gets the best response. Okay. One important thing is that we monitor as much relevant data as possible, as we say here, and display it in insightful ways to quickly detect patterns and abnormalities. And very important, we proactively eliminate the conditions that raise critical alerts. We believe in this, the no broken windows policy, that is, every single alert has to be basically addressed, and every critical alert has to be eliminated, so that when a critical alert happens, we know that it's something serious, because none of them should happen in the normal operations. Now, this is not a trivial thing to do, because, well, one question is, how do you monitor hundreds of servers? And for those of you who have been using cluster monitoring, well, now we have a way of managing hundreds of or tens of graphs in a single, very convenient way. But if you want to know what happens to a collection of servers, all of them the same, it's very difficult by just looking at individual graphs. So we have spent in development a significant amount of time to try to provide new ways in which we can consume this data. And some examples of them is basically what we call stack graphs, and these are stack graphs and heat maps. And stack graphs is the same as I'm showing you here, but we basically put all these graphs in a single graph, and we use colors to distinguish all of them. So for example, we can see that the aggregate activity increases at this particular time, and it's very easy to detect that. By doing it, by looking at individual servers, it's extremely difficult. Similarly, we have what we call heat maps, and here the idea is that we basically have two dimensions. One is time and the other one is servers, and we highlight the intensity of some metric for a particular server by using different colors. So for example, here red means that the server has more load, has more activity going in the server, and the green-blue is less activity. So what happened is that when there was an increase in the number of servers launched, some of the servers received more load or more servers than they should, so therefore they became overloaded. And well, we received an alert, and then we were able to look at these graphs and very quickly identify the problem. And well, the problem was that our algorithm that distributed servers into monitoring servers had basically some limitation that if hundreds of servers were launched in a very short period of time, the distribution was not uniform, and we have addressed that recently. Now, once you basically, well, we use RightScale to monitor our customers' servers, but we also use RightScale to monitor our own servers. So the question is, who watches the watchmen? Here you have a chicken and egg problem that is, or an infinite recursive problem that says, well, if we use Meta to monitor the production, what monitors the Meta itself, and where do these monitoring servers live, and where do these alert servers live? So what we have to do is not easy, it's not trivial, is we try to minimize the potential failures and the potential dependencies between systems. In the old days, because we were a small company, we have more dependencies, but we have basically moved away from that. And as we basically exploit more other clouds and also become more a distributed system, we're adding redundancy and robustness to the whole process. However, it's a problem that is an interesting problem to deal with.
And question here that's come in, going back to recognizing patterns or abnormalities in large groups of servers, are those detected automatically, or how is like customer alerts, for example, used to identify problems?
That's a good question. In some of them, we have some limitation at this point, and I think we're going to address it in the future. There are going to be new features that it's easy for us to put alerts on a single server. It's not so easy to put alerts on a collection of servers. That's a limitation that we have right now, and we're basically, it's new features that we're asking product to put on basically priority, on the priority list. So at this point, there are some limits there.
Okay, next question. Are these monitoring tools available to general public, or are they for RightScale private use only?
No, I think our graphics, all of these graphics are available to the free developer accounts for a short period of time. I think we keep 7 days. But for our customers, that is what we sell to our customers, so every customer has access to them. Now, the newest stack graphs and heat maps, right now they have been in beta, so they are not basically available to everybody. But if you want to use them, it's as easy as just contacting your sales representative and basically ask to be included in the beta, and we make it available to you.
Great, thank you.
Okay, so let me now go to what are our favorite RightScale features. Well, like the TV ad, it's saying, well, I'm not only work for RightScale, but I'm also a RightScale customer. We also basically give a lot of input to product about the kind of things that we love. Some of the features have come from operations, from RightScale operations. And we're going to show you the ones that we love the most, and also the ones that somehow we see that they need some improvement because somehow we don't believe that the functionality still is there. Write images, I think, is a very powerful concept. Resist the temptation to build custom images, making sure that the images are very simple, they're pure, and we know exactly what to expect from them. It's also very powerful. Once we have these images and we start using them, we forget about trying to ask, hey, how is this image configured? What is it I want to expect if I launch it? So that's a very powerful concept that we like. Another one is input inheritance, making sure that we can define some inputs at the level of a template or at the level of the deployment or at the level of a server, so that when we launch a new server, these different inputs come from different parts of the hierarchy. Is very powerful because it's very easy to configure and keep in sync dozens of servers. For example, if you want to make sure that all of your application servers are configured in the same way, well, let's make sure that you set the parameters on the template, because as long as they use the same template, they're going to be configuring the same way. Similarly, you have in the deployment servers of different types. And if normally they share some inputs, for example, the name of the application, the location of the code repository. So by setting the inputs in the deployment, you make sure that all of them see the same values. And if one of the servers fail, maybe at 2 a.m. and you have to launch one in the middle of the night, it's a lot of confidence to know that when you click that button, the server that's going to come up is going to be exactly the same as the one that you're basically phasing out. Similarly, server templates it's a very powerful concept. We really love it. It allows to reproduce configurations across production, staging, and development, and basically have full confidence that things are going to work out the way we expect. Similarly, the component library, we're trying to making a lot of effort to start making the library available to our users and also to encourage them to contribute with new scripts and new server templates, new macros, new solutions. And the nice thing is that if sometimes we need to do something new, it's easy to find an example in the component library that we can leverage and adapt. And obviously monitoring, it's easy to make a collective plugin to monitor just about anything. And once you have that, you can put alerts and basically you can sleep well at night knowing that someone is watching your server.
So question for you before we move on. How are server templates different from machine images like AMIs or templates you see in other cloud environments that are basically VM images?
Well, the difference is that the other ones in a way are baked. The solution is baked there. And in server templates, you have a way of configuring and changing things. So in a way, it gives you the flexibility of making variations out of the server template, but at the same time making sure that the essential things on the template stay the same. In an image, you have to remember what is that you put in that image. And when you launch it and make changes, and then you bundle and produce a new image, well, there is no guarantee that what you have there is really what you want, or it's exactly the same or what you had before. So for the point of view of control of the evolution of a template and the server, we find server templates more flexible and more powerful in that sense.
So it's effectively like bootstrapping servers, dynamically and you've abstracted the configuration away from them.
Yes.
So the abstraction the configuration is very clear, very simple,
yep.
And then it's applied at runtime and reproducible.
Well, the server template is it's open. You can look at the scripts and know exactly how your server is going to come up. Just look and say, okay, I know that I'm going to install my SQL, and this is the way that I'm doing it. This is the configuration file that I'm basically modifying. So therefore, I know what is going to be the end result.
And what types of things are in the component library?
Well, it can be anything that can be configured to do something. Either a script that allows you to configure maybe something on the server, for example, install logging so that you can send information to some external facility, or maybe installing a Tomcat, or maybe Django. Everything that normally you do with a server is whatever a system administrator does on a server to configure it to do something. It can be captured either as a write script and a collection of write script that basically defines a complete server. It's just what the server template is.
Okay, thanks.
Okay, so what are our not so favorite features? Well, server template inputs, they're very powerful and they're very flexible, but sometimes there are too many of them and makes templates difficult to use. What happens is that you start with a server template with maybe 5 inputs, and then someone comes and says, hey, this is wonderful. Let me just extend it so that I can control these parameters so I can make it more flexible. And suddenly your 5 inputs becomes 10, and then becomes 20. So then when someone new, you want to give it to a new person or maybe to a customer, he needs to learn all those 20 parameters, which ones are relevant, which ones are not relevant. We need to do a better job at documenting them, providing tools to our users so that we can highlight the essential parameters, and we basically hide those that are more optional and maybe advanced. And we have some ideas, and I think in the future we're going to see something in that direction. Revision management. So for example, we publish a new template. How we will make sure that our customers see the new changes. Sometimes they use our template and make changes to our template. So they have their own version of our template. So if we produce a new one, how do they know what changed from our latest revision relative to what they have? And what's going to be the impact of the changes we're applying? I don't think we have the right tools at this point. We have made some efforts, but I think we still have a long way to go. Similarly, the component library, sometimes finding new resources from the library is not easy or intuitive. I think we still have some work to do. And finally, alerts. They work pretty well, but they're not easy to configure, especially custom ones. I think that new users, sometimes they have some difficulty getting used to them.
Okay, and two questions related to revision management and automation. The first is, how do you handle security updates in your write images? And the second is, do you use Chef or something similar to automate upgrades to servers?
So the first one is security updates. Well, normally the way we do it is we produce a new version of an image that in a way incorporates these security updates. We try to minimize the impact to our customers. So once we put an image there, we make sure that we don't apply changes that will be surprises to our customers, because they rely on basically the consistency. But well, we try to inform them in some cases when things have to be changed, and we have applied new packages and produced new revisions. And the second one, do we use Chef? Yeah, we provide Chef. Basically, is something that some of our users are user, and we use ourselves. I don't think we are leveraging Chef as much, but we believe that Chef is the future, and we're putting a lot of resources in trying to make it simpler. I think that our first solution for Chef was not as simple as we wanted, and we need more work in order for people to really embrace it.
Okay, here's another question. What types of activities and applications are in RightScale's sweet spot, and where do you fit on the infrastructure as an application or platform, infrastructure as a service or platform as a service stack?
Okay, so, well, I would say that there's a lot of application activities that are in RightScale's sweet spot, but the one is gaming companies, new companies that basically specialize in gaming applications. They have found the cloud as an invaluable resource, because it allows us to basically launch these new games, and if the game is very successful, it can scale extremely fast by just using the resources of the cloud and by using RightScale. So we have had a lot of success in attracting them, and we have very powerful customers who are using RightScale. So I would say that that's a sweet spot. So anything that in a way requires some dynamic escalation of servers or resources, something that is evolving fast, I think it's a sweet spot. Similarly, grid applications, or image processing or audio processing, we also believe that that's a sweet spot in the cloud.
Okay. And another perspective on this, tell me if you agree, RightScale effectively manages infrastructure as a service. We present effectively as platform as a service via the server templates, standing up the solution stack of your choice, where you can change out any of the components independent of the operating system, the language, the development applications that you're using and supporting middleware. All of that's fully tunable down to the infrastructure layer, and then it is sold software as a service. So it really runs the spectrum of cloud.
I agree with you. I would say that as a platform as a service, RightScale in a way is more flexible. It allows you more configuration and more control as opposed to the standard or conventional platform as a service.
But it delivers those similar accelerators.
Yes. Yeah. Okay. So let me go to best practices for upgrading RightScale. I think I wanted to use some concrete example of how we do things in RightScale. So some basically introduction here is, in the cloud, the cost of duplicating servers is minimal. All you have to pay is for the time these servers are basically running. That means that when we basically upgrade our site, we leverage this, so we avoid upgrading existing servers. That normally is the non-cloud approach, and we always launch fresh ones when possible and basically install the new software. The idea is that in a way we fail forward and allow us to have both the old and the new servers. So if something goes wrong, it's easy to recover, and it gives them more flexibility. It's clear sometimes we launch additional slates to capture recovery points and make sure that we know exactly, we have a snapshot of the database, either when we start the upgrading process, or when we finish upgrading, or when we open basically the doors to our users, so that if we have to recover, it's very easy to recover by just reinstalling a snapshot, or just by failing over to one of the slates. So I think another principle is, don't forget to take snapshots in case of major failures. Make sure that you have one. So I'm going to illustrate that. So I'm going to give you a step-by-step description of how we do, how we upgrade our RightScale for a major upgrade, things that we do normally 6 to 8 weeks every time. So this is more or less in a very simplified way. Our application, we have the front ends here, and they basically talk to our main application, and they talk to the databases, and we have some master slave doing replication. Okay, so that's very, very simplistic. So normally what we do is we launch a battery of new servers in which basically we have the new code. And the idea is that, well, we don't make it available because we haven't yet do the actual upgrading. But the idea is that we basically launch new servers, and that's very inexpensive. Now, once we have that, what we do is we also launch a new database. And the reason for doing that is that we're going to basically take we're going to capture a point in time for the database, so that if we have to recover, we can use that extra database. Okay. So we have database that is doing replication, and then the next step is we start our upgrading by basically putting our maintenance page and saying, hey, sorry, we're going to have maintenance for the next half an hour or an hour. So we basically block access to the application servers, and we let these all the activity in our site to basically die down. At the same time, after a couple of minutes, we basically stop all the access to the database, so nothing happens in the database, no changes happens there. Now we're ready to do the actual change, and what we do is that we stop replication in our second database. So we have in this database a perfect image of what was in our database at the point in which basically we stop access to our site, and represents the last action using the old code. So if we have to go back, this is what we're going to fail over to this day. Once we have that, then we take a snapshot at cutoff. So if something bad happens, we always have this copy there. So if everything fails, well, we always can recover from that point. And after that, what we do is that we update the schema. What we're doing now right now is we push all the changes to our database schema. So now the database is reflecting the changes in the new code. And after that, we reconnect the servers so that we make sure that everything is starting to have access to the database, and we make sure that we do our first test so that we have access to all the information, our daemons are working correctly before we open the site to our users. And then finally, we open the access to the site, so now everybody is looking at the new application, the new code, and using the new database. However, we still have the old code and the old servers ready to take over in case that something really catastrophic happens. That hasn't been the case. And we have also a copy of the database to it. Now, we run for a couple of hours in this configuration, and then later on, we just basically disconnect things, and you can terminate the servers whenever it's convenient for you. So I think that's all that we have to present. Thanks very much.
Okay, quick wrap up, and then we'll follow up with addressing some additional questions that have come in. If you have a project and want to discuss how RightScale can help, feel free to contact us at sales@rightscale.com or by phone. We also have the free edition that you can readily sign up for, and a VIP trial option to be able to access the full feature set. There's also a wealth of information available at rightscale.com between a TCO calculator. You can also view all of the videos and content from our last user conference and get a handle on how customers are presenting what they're doing with RightScale in the cloud. We also have an extensive library of webinars like this one and white papers that are accessible. So at this point, let's resume with some of the questions that have come in. The next one was, does RightScale auto-scale our application? So Raphael, could you just comment or elaborate a little bit on how applications get auto-scaled?
I gather that when in the question, our application is basically our customers' applications. Well, RightScale, yes, auto-scale the applications if you have configured them to do that. And the way you do it is basically you use an array, you connect the array to a deployment, and then you basically define some alerts, and the alerts, when they trigger, they execute some actions, and if the action is to launch a new server or to basically shut down a different one, yes, it happens. So the answer is yes, we auto-scale our customers' applications, provided they want to do that and they configure the deployment and the arrays in such a way.
Thanks. This next question is around going back to the meta environment, managing production environment. If RightScale's meta controller itself can't communicate with RightScale's production in one of the availability zones, does it mean customers can't work with that availability zone even if it's up?
No, not necessarily. It depends. I think it depends. There are multiple scenarios. It's possible that not communicating to availability zone normally is not that drastic. It may be that we cannot communicate with some servers in the availability zone either because there is some networking, local networking problems. That doesn't mean that we cannot launch new ones and that our users cannot basically have access to them. I think there are many scenarios, so it's difficult to really typify them with one answer.
Here's another one that's related to availability zones. It was stated at the beginning that servers are put up in multiple clouds and availability zones. How do you handle the different geographic locations for the database servers?
Well, as I said at the beginning, is we have to distinguish between RightScale in the old days and RightScale today and RightScale in the future. Is that in the old days, yes, we used a single database that was just in one region, and as new regions basically came up, or we started supporting other clouds, well, all of them have to connect to our database that was in AWS East. Now we're starting to move away from that and put some services, and once we basically decouple the services from our main database, we can put those services in different clouds and in different regions, so that basically we can minimize latency, and also we can minimize the potential of having a single point of failure. Now, going forward, we're going to try to continue pushing that more and more. So it's a dynamic situation, and I think we're less dependent on a single point of failure, or less affected, and we're going to continue improving on that.
Okay, next question. Does RightScale use a common base OS such as CentOS internally, or is the environment more heterogeneous?
I will say that we started with CentOS OS, and now we're moved to Ubuntu. At some point, we have an heterogeneous, and we have different OSs. I think recently we're basically being partial to Ubuntu, and the reason is there being more changes, more activity. It seems to be a more dynamic distro, and therefore we want to benefit from all these improvements. So we're happy with Ubuntu, but we may have some legacy servers or some other applications in which we still use CentOS.
Okay. Next question, what kind of load balancer software does RightScale use for various services? Is it HA proxy or something more advanced like Zeus?
We use HA proxy. We use HA proxy and that seems to be working pretty well for us. That's what we basically offer in our premium templates, our front ends. It's HA proxy. And so far it has worked very good for us. The activity on the front end seems to be not that high, and we're happy with it.
Okay. Next question, is the launch new server approach, i.e. fail forward, also used for basic maintenance, such as patching?
I think it's on a case-by-case basis. It depends. In some situations, we use that because it's in a way cleaner. In others, it may be an overkill. So I think that is more like we ask ourselves the question, can we do it that way, and is the right way of doing it? And the answer is yes, that's the approach. But sometimes especially maybe after a couple of maybe the first 2 days after release, sometimes we have to do frequent upgrades. So it will be basically very inconvenient to try to launch for every upgrade. So we do it basically on the servers themselves.
Okay. Next question is around security groups. How do you handle security groups? Do you create a group for each server, or does each server have multiple security groups to handle different access needs? Do you have any best practices advice on using security groups?
Yeah, we basically we look at the architecture, basically all of the servers, and we partition the servers based on the role. For example, the databases, the app servers, the front ends, the daemons, all these things. And we normally put a class of servers within their own security group because they share the same security requirements. So for example, the databases, normally they are all together in the same security group because either whether you are a master or a slave can become a master, so in a way they have the same requirements. And then we put relationships between, the minimal relationships between the security groups so that the server can only be accessed and can access the servers that it needs to do its work. And we try to be pretty again, conservative in making sure that we err on the conservative side. Yes.
Okay. And concerning the API, do you use the cloud vendor-specific APIs or SDK, or an open source cross-cloud API, or something homegrown?
We use something homegrown, and we normally make them available. I think we have tried to make these gems available to the public. So, yeah, we do that.
Okay. The next question is, what's the difference between AWS's new autoscale feature and RightScale's? And I assume they're talking about Elastic Beanstalk in that case.
Yeah.
I can readily address that. I mean, Beanstalk is a platform as a service offering. It's effectively Amazon's entry into that market, similar to Microsoft Azure or EngineYard or Google App Engine. It's really aimed at providing a simple-to-use cloud deployment framework for developers. In contrast to that, RightScale is a full cloud management platform. It provides a complete deployment environment across many infrastructure as a service cloud providers. It also delivers automation across the entire application lifecycle, so from development, test, production, and so forth, while preserving complete flexibility along the way and freedom of choice. So it's multi-cloud, multi-operating system, multi-language. Your full choice of programming language and middleware, and then it's architected in such a way with server templates and deployments that it's portable across cloud infrastructure, be they multiple public clouds or into private cloud infrastructure. And similarly, it's supported by RightScale's back-end service and support group that has great experience onboarding customers to the cloud, and then we've managed some of the largest scaling events on the cloud today. Next question, what are the key advantages of RightScale monitoring over and above Amazon CloudWatch?
I think that we go deeper and we provide more monitoring information than what AWS CloudWatch is providing right now. I think our new graphs, the stack graphs and the heat maps, it's something that you can only see on RightScale today. And we're going to continue basically innovating there and providing tools in that direction. So I think at this point our tools are more powerful, more flexible. That doesn't mean that CloudWatch may not be the right tool for its own applications.
Cool. And with that last question, we're going to wrap up this webinar. Thanks so much, everyone, for joining us today. We've appreciated your time and hope you've learned a lot. Just to reiterate what Chris said earlier, our webinar has been recorded. Once we close this out, we just need to compress it. We'll upload it on our site, and it will be up later this afternoon so you can watch it again and relive the magic or share with your friends. Again, thanks for your time. Doug's going to be staying on the line to answer any questions you might have, but this concludes the live portion of our webinar. Thanks again.